Hey, let's talk about polynomial long division. So we're going to take two polynomials, we'll call them f of x divided by g of x, and we just don't want g to be a zero polynomial. And what we're going to end up with is some q of x called the quotient plus some remainder of x divided by g of x, where the degree, which is usually denoted by this little backwards looking 6 of r, is less than the degree of g. So there you have it. What we're gonna do is we're gonna take it here, and f might have a higher degree. It might be, say, a 5th degree polynomial divided by a third, and eventually what you'll find is that'll give us a 3rd degree polynomial in a quadratic, for instance. Okay, so how do you do this? Well, I better just show you an example. So what we're going to do is we're going to find x, let's say cubed plus 2x squared plus 3, 1, 2, 3, go figure, divided by x squared minus, let's say 1. Oops, that's an exclamation point, minus 1. Okay, and we just want to write this as some polynomial plus some other polynomial divided by x squared minus 1. So to do this, you might think we should just start by drawing the little division symbol from dividing numbers, right? An x cubed plus 2x squared plus 3, and try dividing into that 2x, or x squared minus 1. And you'd be absolutely right. This is exactly what we should do. And the only weird thing is, what would you multiply this by to make it work here? And quite literally, we're just going to think of the powers of x as digits. If you remember from long division, you look at what to multiply this thing by to make it similar to this, like not quite as big. And what I'm going to tell you is you take the leading term, you take x cubed, and you divide it by the other leading term, which is x squared. That gives you x. And that is exactly what you write here. Because now look what happens. When we multiply this x by x squared minus 1, we get x cubed minus x. And just like with regular long division, we subtract that from this other polynomial. The x cubes cancel. There's a 2x squared plus x plus 3. And now what do we write? What's the next piece that goes up here? Well, we take 2x squared and divide it by x squared. So 2x squared divided by x squared. And what we get is 2. So this should be x plus 2. And let's try that. We'll multiply it out and we get 2x squared minus 2. And remember, this is polynomial division, so it works like regular division. We're subtracting. So the 2x squareds cancel. We have an x plus 3 minus negative 2 is x plus 5. Now I'm going to go ahead and tell you this is our remainder, and there's several different rules here. If you keep trying to go, you'll end up with something that's not a term of a polynomial. You'll end up with like 1 over x as the next thing you write here, which is fine, but you don't want to do that. Because what we want to do is we just want to write this as x plus 2, and then we want to write the x plus 5 here. That's it. And the way you know to stop is when this thing has a smaller degree than this thing. It's all about these degree numbers. Once you've satisfied the degree of r is less than the degree of the denominator, you stop. So at this point, we're done. I'll put even, if you remember, r for remainder, x plus 5. So there you have it. Polynomial long division takes a quotient of polynomials, turns it into a quotient plus a remainder over the divisor. Thanks for watching. See you next time.